the first thing that you want to do to find the reflection coefficient for part A is realize that the equation for it, or I should say the magnitude actually, so I'll just put a little magnitude here, is equal to the load impedance minus the characteristic impedance over the load impedance plus the characteristic impedance. So since we already have our characteristic impedance, we're good there, but we need to solve for our load impedance, which is our resistor and inductor in series. So we can simply say R plus J omega L. Plugging in our numbers, we get, and we see 5 megahertz, so we can use that for our frequency. So we say 2 pi times that, so it's the same as 10 pi times 10 to the 6th, also times our inductance, so we have 0.02, 10 to the minus 3, so then we have 600 plus J, plus J 628 ohms. Okay, so now we can go back to our reflection coefficient here, and we can get 600 plus J 628 minus 300 divided by 600 plus J 628 plus 300. So we can simplify here. And we can convert these to phasors and then simplify that way to divide these. But I'm just going to calculate this to save some time here. So we have equal to 0.63. Okay, so that will give us our final answer for our reflection coefficient. Then we want to solve for our standing wave ratio, which now that we have our reflection coefficient should be pretty easy. It's simply okay. Shouldn't say I think I said magnitude here, and we're actually calculating for the full value. Yep, we are. So yeah, let's just pretend that those weren't there. You're just solving for your regular one because we actually have to take the magnitude here. And that's simply this component right here. So we can do 1 plus 0.63 divided by 1 minus 0.63. Okay, and then this gives us 4.405. So S equals 4.405 is our standing wave ratio, which is a dimensionless unit. So now we want to solve for location of the voltage maximum nearest to the load. So that would be our L max equation. And this is simply so this theta r here is a theta r from our reflection coefficient. So we have times pi over 180, and then we multiply by our 60, and I computed this before, but just to show all the steps. The way I got this wavelength here, simply our speed of light divided by our frequency, and this is just equal to that 60 that you see here. So this is, we have divided by 4 pi. So then we can simplify. This will give us 2.46 meters. Now, going on to our minimum length, which we can get from since we know that the current maximum and voltage minimum are the same locations, we can say that our L max is less than the wavelength divided by 4. Therefore, we can say our thing here is equal to 15. So we have Lmin equals 2.46 plus 15, 17.46 meters. And that is that. Thank you for watching.